just to give a quick comparison of the various molecular methods. So flow cytometry, real-time PCR for the translocation, and allele-specific PCR for the immunoglobulin or the T cell receptor. Finally, the NGS. So the sensitivity is, the flow cytometry is sensitive up to 10 to the power of -4, whereas PCR can range for 10 to the power of -4 to 10 to the power of -5. And the NGS has a sensitivity of 10 to the power of -6. Detection method, almost fluorescent is the detection method for all, but of course in flow cytometry, it is antibodies tagged with fluorescent dyes, which is going to detect the cell surface markers, whereas PCRs have primers or probes, depending on the type of PCR, which are tagged with the fluorescent molecule. And in NGS, every nucleotide is tagged with the fluorescent molecule, and that is a method of detection. The TAT is, of course, the least for flow cytometry. As soon as it gets to the lab, it's just 3 to 4 hours time that you get the flow cytometry report. Real-time PCR for translocations, it is around 4 to 6 days. And for the allele-specific, ASO PCR for immunoglobulin or the T cell receptor repertoire, it is around 4 weeks. That is purely because you have to identify the sequence by sequencing the immunoglobulin repertoire of the patient, then design primers for the specific allele that is there in the patient, and then you have to do the PCR, which takes anywhere from 3 to 4 weeks time. Finally, the NGS does not require patient-based customization, and the turnaround time is around 2 weeks. Standardization, flow cytometry is a well-established protocol, well standardized by various consortia across the globe. And for real-time PCR, also for certain specific translocations, you have a well-standardized protocols like PCR, ABL, PML, are quite well-standardized across the globe. For the ASO PCR for immunoglobulin and the T cell receptor repertoire, you have limited standardizations available. It's still a long way to go. Whereas for the NGS, particularly the FDA approval is specific for the immunoglobulin or the T cell receptor, which is detected by the NGS. Whereas the NGS method for other mutations still needs standardization. Patient-specific reagents is required only for the allele-specific PCR for immunoglobulin and the T cell receptors, whereas the others do not need patient-specific reagents.